Thank you. And Gregor, thank you for that presentation. Nice segue for me. And we worked together on the Falling Walls jury in Berlin in November, and it's nice to see you again. But look, the segue is that Airbus actually demonstrates a lot of what we require in fusion. The capability to develop new technologies and integrate those technologies and put them into the market. And of course, Airbus has quite a history, and it does the most extraordinary things in manufacturing in different places and bringing those very complex components together. I don't know if you ever sat on an A380 on the runway and seen those wings dipping down like this, and then look out the window when you're flying, and that flex is just an engineering dream for me. So there's a direct relationship with what I am going to say to you about what is needed in fusion. And Gregor, you mentioned ecosystem readiness, and that's what I'm going to talk about now for the next 10 minutes. Because we are on a journey, as most of you will probably know. UK Industrial Fusion Solutions is the newly created, 1st of November, we became a standalone public-private partnership with a single shareholder of the British government. And our duty is twofold. One is to deliver in the UK a fusion power plant to demonstrate that this will work and deliver electricity on the grid. And we're targeting 2040 for that. Now, I don't want to disappoint you with that timeline. And you all know how urgent the need is to get clean energy out into the market, particularly with the pace at which the climate is changing. I was at Oxford University as Pro-Vice-Chancellor during COVID. And if you talk to our vaccine team in 2019 about how long it would take to produce a vaccine for COVID, they'd tell you 12 or 15 years. We did it in 12 months. Why did we do it in 12 months? Because people were dying in the street and we needed to do something. And we put best minds together, a massive effort together. We partnered with an amazing company, AstraZeneca, and we rolled out more doses of vaccine and saved more lives than any of the other vaccines that were produced. So I know that complex technologies can be developed more quickly. And maybe on one of these platforms in a year's time, we'll talk about that time horizon in a more realistic way, whether it is possible to achieve a faster development time. But before that, we need to consider our second part of the mission, which is creating the pathway to commercialize fusion. So everything that we do in UK IFS has to pass the commercialization test. Now, there's some wonderful capabilities. I was chairman of the UK Atomic Energy Authority, which is our fusion partner and the national laboratory and world leader in fusion, doing wonderful work in the sciences, and we need to accelerate that. But you don't always have to pass a commercial test if you're in a lab or trying to prove net energy. If you're trying to deliver a pathway to take fusion into a market, everything you do has to look at the commercial viability. And that's why we're building STEP, the spherical tokamak for energy production. We've finished our first phase of design and entering the detailed design phase at the moment. We, as you probably know, are going to demonstrate net energy, fuel self-sufficiency. Now, there's a lot of technology to be organized and thought through, and some deep science to be worked up in terms of breeder blanket and creating our own tritium, as some of you in the room will know more than I do. So there's a lot of development work still to do in creating self-sufficiency. And importantly, plant maintenance. Now, Gregor talked about uptime. You're not going to fly an aircraft in any time where you've got to stop and maintain that mid-flight. You need to have reliable maintenance cycles. And so we're designing a plant with that as part of our course specification. And of course, we have the delight of having the Joint European Torus being decommissioned on the Atomic Energy Authority campus at Culham, and learning how to do that using our robotics capabilities, which are going into our design flow. But the big point here is to do any of this, we have to create new industrial capacity. And the science and technology that we're developing is now to some extent bounded. We know what problems we're facing. We know what the boundary lines in most of those problems are. And each one of these areas now is a problem set in technology, which is a great challenge to stimulate new industry. And on this chart, if you can read it, you can go round all of these points. And each one of those, you can see innovation happening. So this is, when people think about fusion, it's an integrated technology. It's not something you can have a single patent on. Each one of these areas is a field in its own right. As you surely will know, and some of you come from some of these areas, and they're part of our supply chain, part of that industrial ecosystem that we need if we're going to make fusion a viable option in the marketplace and build out. And so we are eyeballing each of these fields, and each one is starting to spawn off capabilities in their own right. New companies are being formed. Existing companies are coming in and starting to address these issues. That's great. You can draw that picture, but can you make it work? Well, we think the second part of this challenge is organizational. Unless you've got an organization that can systematically pull together and command this and become the forcing house for those different strands to work together in an integrated design, it will not happen. And one of the reasons why the UK set up STEP and the UK Industrial Fusion Solutions was to create that forcing house and say, rather than go down the swim lanes of fuel supply, robotics, new materials, magnets, and so on, we are going to commission bringing that all together. So UK Industrial Fusion Solutions is the intelligent client, it's the owner, it's where IP sits, and it will be the financier of fusion in the UK and elsewhere, first of all with STEP. And we can talk more about how we're bringing that together. The whole plant partner, UK Atomic Energy Authority, is on board. Over this year, we are working to bring on board the whole plant engineering partner. There's a fantastic consortium. And then there are several bidding for the whole plant construction partner. When we've got those on board, we have industrial strength and the private partners we will need to make this happen. On the journey, we need to bring in further partners that already exist. And some of you are in the room. Thank you for being great partners. And we would like more. I've only put a smattering up on this slide just as a tease, of course. And some come from outside of the fusion sector, like NVIDIA, who I'll be with next week in California, or Eni, the Italian oil and gas company, which is partnering with us on tritium. Now, we would like more big players from industry, from the precision engineering area, to come into this endeavour. And so there's a direct ask for you, if you're in the room, Airbus, please join forces. We need your awesome capabilities. I mean, your integrative capabilities to put aircraft together from different factories is something we need to learn from. So I can see you could be a great partner with us as well. But look, we can't do any of that without talent. So a major stream of creating that industrial ecosystem is about the people. We've already invested heavily at Culham in what I think is an absolutely superb talent creation engine room. It started off as the major apprenticeship capability, doubled in size now to degree level apprenticeships, and we'll be setting up more of those and creating the people without whom we can't have an industrial supply chain and people to work in our design. By the way, we've got about 1,620 people working on the design of STEP at the moment. So, you know, we've got some bench strength, but we need a lot more. And then, of course, on the journey, we are creating value. So STEP is an investable as far as the government's concerned. You know, a recent review independently of how much value is being created bearing in mind what we've done to date is design work. We haven't actually built a power station from STEP. We've got about 1.4 GVA. That means for every pound that the British government puts in, we can give them the pound back plus 40 pence. That's a very good investment. Why? Because in stimulating this forcing function, we need solutions that are creating opportunity in adjacent markets. So, for example, creating remountable magnets, high-temperature superconducting magnets, was a design that we need for maintenance, but it's stimulating opportunities to take those magnets into other markets. And we've just got a little list here of areas where we've already started to measure some of the solutions that we need being adapted and creating value in related and adjacent industries. There's a couple missing from here, at least. There's satellites in space and the aerospace sector. There's defense, where there's quite a lot of capability that we're sharing. And of course, there's finance. So to really deliver on this, we need to work across the patch. And just one little example, which is just live at the moment, to bring our fusion plant up to temperature. We were on the jet using neutral beam heating systems, but they take up a large real estate footprint right next to your vessel. And we need that footprint now for putting a breeder blanket round and doing other things with. So we're switching our ideas towards the microwave heating system. Well, that's stimulated an awful lot of interest. And new ways of guiding and managing microwaves, we could probably put them tens or even 100 meters away from the core vessel. And that would liberate space for our machine to be designed and used. And we're already starting to see discussions into telecoms, into defense, and into medical from the work, and new patents being created, stimulated by this design. So these are some of the ingredients that we need in order for us to fulfill our mission of building out on the demonstration power plant in this country, in North Nottinghamshire, at West Burton. And we can't do it without creating that supply chain. And, the best and boldest endeavours start with a practical step. And that is real in many senses of the word, because without the forcing function, we'd be down our tramways doing great science in magnets and elsewhere without necessarily putting it together and understanding how to do the integrative work, which I think Gregor has shown us a company like Airbus has been able to do to great effect and produce amazing technology that we all enjoy using. So it's to the future that UK IFS might boldly step to become the Airbus of fusion or the NASA of fusion. We see ourselves creating an industrial endeavour like that, but we need the ecosystem to be formed right now for us to succeed. Thank you.
David, thank you very much. That's an inspiring vision. I would love to see you become the NASA of fusion and have it based in this country. It'd be amazing. Does anyone, you must have lots of questions for David. Gregor, why don't you start? And if there's others, please put your hands up as well. Do you want to wait for the microphone just one sec? If there's any other questions for David as well, keep thinking. Yeah.
David, thank you very much. It was great seeing this undertake, and you are the best person to lead it, honestly speaking. Questions I have to you: why this time should be different for UK or for Europe? If I will look in the past, we had a great undertake. If we talk about the photovoltaic, if we talk about, for example, this what we were doing in area of the batteries, where we said we are going to be investing from governmental side, some private money and so on, but then we had not enough patience in order to overtake this gap where suddenly the product was still not ready to commercialization, and then we just gave up. Why this is going to be different?
Well, first of all, thank you. It's a great question. I think we're at a slightly different stage of maturity in terms of where we are with fusion compared to when Europe and Britain came into photovoltaics and batteries. there were already leaders who were better than us in manufacturing photovoltaics, particularly outside of Europe. At this point in time, there isn't a clear leader better than some of us here in fusion. So we have already got a pole position. I'm not complacent in the slightest, and there are very, very good players elsewhere who can steal that position, and good luck, we need them to. But we, at the moment, have a claim that we can keep driving this forward, and we can drive it forward very fast. And if we don't, it's us to lose, right? So that's really where I think we're at, and we need to be confident about that. Yeah.
Okay, David, I think we've run out of time now, but thank you very much for all of that, inspiring vision.
Thank you.
Thank you very much.